What is a matrix? A matrix consists of a set of numbers arranged in rows and columns enclosed in brackets. So when we see numbers represented in this way with these square brackets around them, we call this setup a matrix. So the example on the screen shows a matrix that has 3 rows and 2 columns. We call this type of matrix a 3 by 2. Alright, so here we go, 610, 5302 is an example of a matrix that has 1, 2, 3 rows, and there are 2 columns, column number 1, column number 2. Each one of the numbers in the matrix is known as an element of the matrix. Alright, so as stated before, the dimensions or order of a matrix gives the number of rows followed by the number of columns in the matrix. So using the same example of 610, 5302, the order of this matrix will be 3 rows and 2 columns, or 3 by 2, or written out with the word by in between, 3 by 2. It's usually represented in this format with a multiplication symbol between them. So we usually denote a matrix by a capital letter. So in this case, capital C would represent all of these numbers. So what is the dimensions of the matrix C? This matrix C is a matrix of order 2 by 4, meaning there are 2 rows and there are 4 columns. The elements of a matrix, as mentioned before, is each number in the array. An array is another name for the word matrix. It's called an entry or an element of the matrix. So we're going to use the words in this example, matrix and element, even though they're interchangeable with array and entry. Alright, we need to read out the elements of an array. When we need to, we read it out row by row. So the elements of this matrix, for example, would be read 2, 3, 4, 6, 7, 8. Alright, so each element is defined by its position in the matrix. In a matrix, let's say it's A, an element in row I and column J is represented in this format. So the letter A represents the matrix, I would represent the row number, and J would represent the column number. So A11, for example, is read as 11, it will mean the first row and the first column. So the item is the first row and the first column will be the number 2. A12 will be first row, second column. In this case, that number is 4. So what is the element at the given position? What is the element at A13? That means first row, third column. That number is 5. What element is at A21? That means second row, first column. That element will be 7. A22 will be 8, and A23 will be 9. Now, once we have matrices, we could go ahead and perform some simple operations in them. So the first operation we're going to look at is addition of matrices. So if I have a matrix A and a matrix B and they are of the same dimensions, addition only works when they are of the same dimensions. So this is an example of a 2 by 2 matrix. There are 2 rows, 2 columns. And this is another 2 by 2 matrix, 2 rows by 2 columns. We could go ahead and perform the addition because the dimensions line up, the dimensions match. So what we would do, we would take the element at A11 and add it to the element at B11. And I've color-coded them so you'll notice that they go together. What we get is the following, 1 plus 5. And I'll move through my matrices in the following format, row, then column. So the next item in this row would be the 2 and the 6. I add those together. The 3 and the 7, add those together. The 4 and the 8, add those together. Alright, my final results would be 6, 8, 10, 12. Alright, so when I add matrix A plus B, when I add matrix A to matrix B, my result will be this matrix, which is going to be a 2 by 2 matrix. Notice that the result comes out to be in the same dimensions as the parents. Okay, so these two objects were 2 by 2, the result has to be a 2 by 2. If we are having something else, we have done something wrong. Okay, so subtraction works in the same way. Subtraction says take the corresponding elements of both matrices, in this case matrix C and matrix D, and subtract them. So 10 subtract 6, 14 subtract 4, 3 subtract 10, 9 subtract 14. My result will be 4, 10, negative 7, and positive 14. Okay, so off screen or off camera, I'd like you guys to pause the video and determine what is the value of D minus C. So I'm subtracting this matrix from this one and not the other way around. All right, and what is the relationship between this matrix and the answer for D minus C? Okay, when that's done, we'll take a look at multiplication by a scalar quantity. So if I'm given a matrix E, that's 2, 4, negative 1, negative 3, 6, 8, 12, and negative 2, what is 2e going to be equal to? So if I double this matrix, what is going to be? In other words, if I multiply this matrix by 2, what is the result going to be? Well, procedure is the same, or similar. It means every item in this original matrix gets multiplied by whatever the scalar quantity is at the front. So it'll be 2 times 2, 2 times 4, 2 times negative 1, and so on. My result is going to be 4, 8, negative 2, negative 6, 12, 16, 24, and negative 4. So we've seen the definition for a matrix. We know what a matrix is. We know what the elements of a matrix is. We know what the dimensions of a matrix is. We know how to do simple operations in matrix, such as addition and subtraction, and how to multiply by a scalar quantity.